We have to say whether you can see the screen. Can you see the screen?
Yes, sir.
Okay. Just say once more. Can you see it's moving?
Yes, sir.
Okay. Can you read the word set?
Yes.
Okay, fine. So, when I come to the topic as far as possible, I'll go in the same sequence I shared yesterday. Set. You can say, as I told when you talk about the numbers, if I ask what is a number, then we will have some trouble to define some numbers or define what is triangle. Even if simply say what is a triangle, you will find difficult to define because it all depends on the set, the term set. We can say mathematics, the subject mathematics starts with set. That's what I'm telling you. You're going to start mathematics. What you did till now was without starting. We are going to start mathematics now. So, how you were feeling mathematics earlier, forget about that. You're going to have a new set. Let us start with the set. Let us see. Let us have some introduction to that. What is a set? This I think I shared earlier. What is a set now? The topic set, the theory of set was developed by a German mathematician named George Cantor. The person who introduced set theory is George Cantor. Cantor introduced set theory, and that is actually it is a major branch of, I can say it is the beginning of mathematics. Something has to begin. See, if you say English begins with alphabets, mathematics begins with set theory. So what you studied earlier was not the beginning. Now we are going to start. Set theory is considered to be the base of modern mathematics. Okay? Set theory is considered to be the base of modern mathematics. Let us see what is a set. A set is a well-defined collection of objects. You see, what do we understand by well-defined? Well-defined collection means, what do we understand by the term well-defined? Well-defined means whether an object belongs to the collection or not. See, a collection of objects. What kind of object? Well-defined object. Well-defined object means whether an object belongs to the collection or not can be identified or can be decided without any ambiguity. Without ambiguity means without anyone's opinion. No need of taking his opinion or their opinion to see whether an object belongs to this collection or not. I'll explain it how it comes. Let us take an example. The collection of odd numbers between 1 and 10. Do you have any ambiguity in identifying the elements here? If I take a number 5, yes, it is an odd number between 1 and 10. If I take a number 15, no, it is not a collection. It's not a member of that collection. If I take a number 8, no, it is not, because it is not an odd number. So whether yes or whether no need of going for an opinion. The only thing is that you should know what is an odd number, whether it is between 1 and 10. There is no ambiguity. There is no difficulty. There is no opinion needed. It's a set. Collection of rivers of India. Well, of course, you should know. If I say a river, Nile, it is not a member of this collection because Nile is not a river of India. That you should know. There is no question of opinion. Whether you know or not, that is a different thing. It's a collection of rivers of India. It's a well-defined collection. Collection of vowels in English alphabets. No question, no doubt, no ambiguity, no opinion needed. It is a well-defined collection. Collection of even integers more than 100. Of course, if you go on listing, so many are there. But whether yes or no can be identified. If I say 124, yes, it is an even integer more than 100. If I say 115, no, it is not even. Or if I say 95, no, it is not even more than 100. Okay? The solution of the equation x squared minus 5x plus 6 equal to 0. No doubt, we can find out whether it is true or false. In all the above collection, whether an object belongs to the collection or not can be easily identified without anyone's opinion. So all these what I have written are set. The collection is not a set. Hence all these are well-defined collection and hence they are sets. Any queries? Fine? Okay. Keep up if you have queries, no problem. Now let us take some other examples. The collection of old, tall boys in your class. Come on. If I ask, I just name a boy, say Kiran, whether he is a member of this collection or not. Of course, suppose that he is, I don't remember the names. Suppose he is a boy of this class. Whether he is tall boy or not, who will decide? There may be ambiguity, there may be dispute. There may be dispute. One say he is a member of this, and the other say he is not a member. There is a dispute, there is a question of opinion. Now let us take the collection of talented batsmen of Indian cricket. Well, by Sachin Tendulkar, all of you may agree. But if I say Sehwag, some of you may agree, some of you may not agree. There is a question of opinion. It is well defined. The question is, the term tall boy is not well defined. If there is a question of opinion, who is tall boy? Who is not tall boy? Whether an object belongs to the collection or not is a matter of opinion. You get it? The term tall boy is not well defined. Set is a well defined collection. Here, tall boy is not well defined. It is not a set. Now the other one, who is talented batsman? The term talented batsman is not well defined, and hence it is not a set. Because this term talented batsman is not well defined. Now let us see. Let us redefine the same set or the same collection. I don't use the word set. Same collection, let us redefine. The collection of all tall boys in your class where a boy of height 160 centimeters or more is, I'm going to define what is a tall boy. The collection of all tall boys in your class where a boy of height 160 centimeters or more is a tall boy. Now there is no doubt, there is no question whether a boy, of course he has to be a member of the class, otherwise he is out. If he is a member of the class, whether he belongs to this collection or not, very simple, I measure his height. If he is 160 centimeters or more, yes, he belongs, else no. There is no opinion needed. The term boy is well defined here. Further, second one, let me redefine. The collection of talented batsmen of Indian cricket where a batsman who scored a century in an international cricket is a talented batsman. No question, no doubt now. Well, if you take any name, just see whether he scored a century in an international cricket. Then yes, he belongs to the collection. Of course, he has to be an Indian cricketer. Otherwise, no, else not. So there is no question of opinion. There is no question of ambiguity. There is no question of opinion. So these are, we can easily see that the above collections are very much set because they are well defined. So set means a well-defined collection of objects. Now we are going to have some notations. We are going to use capital letters A, B, C, D, etc. You can use any letter to denote a set. The name of a set. We can have names for the set where small letters denote its elements. Small a, B, C, etc. are used to denote its elements. And element A is an element, an element of the set A. We write, you see this epsilon. It's a Greek alphabet. It's epsilon. We read this A is a member of A, or we simply A belongs to A. We read it A belongs to A, or you can simply say A is a member of A. Take care how we read it. A belongs to A. And if it is not a member, we read it, say B. If B is not an element, we say B does not belong to A. A belongs to A, B does not belong to A. Or A is a member of A, B is not a member of A. You can use any of these. B does not belong to A, or you can say B is not an element of A. See, be careful, we use these notations quite frequently. Example, if you have set A is equal to, what are the elements here? 5, 6, and 7. You can say 5 is a member of A because 5 is here. Members are 5, 6, and 7. So we have 5 members of A, 5 belongs to A, 6 belongs to A, 7 belongs to A. What about 8? 8 is not a member of A, or I can say 8 does not belong to A. 9 does not belong to A. That is how we make notations. Okay? Representation of a set. To represent a set, we have two methods. One is roster form, also known as tabular form or listing method. In this method, we list all the elements. Simply list all the elements separated by commas, and we are enclosing it by brackets, curly brackets. So for example, if we have, as I told, we use the English alphabets A, B, C, D, etc. for name. A is equal to 1, comma, 3, comma, 5, 7, written with the brackets. Remember the notation? We use curly bracket or bracket for the boundaries. And we have elements, numbers separated by commas. We don't worry about what order. There is no need of worrying about any specific order. Say if I have B, is another set. Elements are here, A, E, I, O, U. I have just written with brackets, and the elements are listed, separated by commas. That is known as the roster form. Take care about the name roster form, or tabular form, or listing method. Now there is another form of representing a set which we call set builder form. Now itself set builder form, or simply rule method. Rule method, we are giving the rule. In this method, we describe the rule by which the elements of the collection are decided. Rule method or set builder form, how the set is built up. Set builder form. The other one is roster form or listing method, tabular form where we list the elements. Here in set builder form or rule method, we give the rule by which the elements can be decided. For example, as I told, the name I'm going to use any letter, English alphabets, B. The collection of integers between 1 and 5. Of course, I have written the set B, in which method? Set builder form. If you want to write the set B in listing method, what will be the elements? We can write that as 2, 3, 4, separated by commas. So you can change from one method to another method, no problem. Both are set, written in different form. The collection of integers between 1 and 5, when you write in listing method, it will consist of 2, 3, and 4. Between 1 and 5. Integers between 1 and 5. You have to read very carefully. Okay? Let me pick up another one. Generally, we write represent like this. We read it C equal to, I can read like this. Collection of X such that. You read it like this. Or you can simply say set of X such that X is an odd integer. Set of X such that X is an odd integer between 1 and 10. How do we read it? Set of X such that X is an odd integer between 1 and 10. You see, this is a very standard notation, standard form, how we write this, this set in listing method, rule method. Okay. We read it like this. Set of X, read it like set of X such that X is an odd integer between 1 and 10, and we close it right. How do we read it? Set of X such that X is an integer, X is an odd integer between 1 and 10. Another one, set of X such that, this is B, C, and this is D. Set of X such that X is an alphabet of the word allow. Now, if I ask you to list these, B, you will list 2, 3, 4. C, you will list odd integers between 1 and 10. 3, 5, 7, 9. Between 1 and 10, odd integers. 3, 5, 7, 9. And D, when I list A, L, C, no need of repeating an element in a set. When I say the alpha set of alphabets in the word allow, no need to write L 2 times. We only need to write A, L, O, and W. No need to repeat. There is no need of maintaining any order in the collection. Right? While representing a set in roster form, that means listing method, no specific order is to be maintained. We don't worry about which comes after, which comes here. This set has nothing to specifically do with the order. Where is it written has nothing to do. And second thing is that repetition of any element in a set is not necessary. I don't say, even if you say in the previous one, if you say A, L, L, or if you repeat an element, there is no danger. I cannot say it is a mistake, but not necessary. Why should we repeat an element unnecessary? So we know we don't need, I can only say we don't need to repeat an element in a set. Take care of this. No need to keep a specific order. There is no necessary to maintain any order, and no need to repeat an element in a set. Okay. Well, we have defined the set. I hope you are comfortable with that. And you know when is a collection a set and when is it not a set. You take care of the notes very carefully. I will share the videos for you. Sit and write the notes, then you will come to know. And I am just guaranteeing you don't have to worry about anything else once you make up this completely. And do all the questions which I share. I am going to share some questions for you. And once you do that, you can take it granted it is done. Find which of the following are set. Justify your answers. A collection of all months of a year beginning with the letter J. You only say whether it is yes or no. And if it is no, justify. And if it is yes also, you can say a word. Justification. Collection of most talented writers of India. Should I help? Collection of 10 top most talented writers of India. I'll help here. You say the second B is not a set because. What is the reason? Most talented writers of India is not well defined. The term most talented writers of India is not well defined. Same collection of 5 dangerous animals in the bird. You have to find whether it is a set or not. If no, give the justification for that. Collection of all creatures of earth. Now I am leaving the rest for you. Collection of all, even natural numbers less than 10. Less than 2. Even natural numbers less than 2. Collection, yes or no, whether an element belongs to this or not. We can find whether without anyone's opinion, yes or no without anyone's opinion, then it is set. You should answer today itself. Collection of 5 clever students of this class. 5 clever students of this class. Now, fill in the blanks with belongs to or does not belong to. Suppose A is equal to 1, 3, 4, 7, 8, 9, 10. 3. Well, you can easily find. I don't have to help you. Right? Write the following set in roster form. Roster form means you have to write in listing. You will sit, read, and answer it. Right? And see, for example, D, set of all x, so that x is an integer, more than 100. You have to list them. I know, if you start listing, you will never end. You come to some points and then you write dot dot, no problem. Write the following set in set builder form. Now it is up to you how you represent this in set builder form. You write and send the answers to me today itself. If you don't find, or if you find difficulty, that also you tell me. Match each other following set in the left side given in roster form with the same set on the right side in set builder form. First one is 1, 2, 3, 6 here, 2, 3, ALOWS, 2, 3, 4, 5. And the right side, X is an integer between 1 and 6. X is the letter of the word, it's a prime factor of 6, it's a natural number and factors of 6. Now you list, now you have to match 1 with which one, 2 with which one, 3 with which one. I hope you have followed this. I will share the screen for you, right? I will share the recordings for you.